Okay, I'm Robert Lupton. I sit over at the university. I'm going to talk about something quite boring today, and I'm going to talk about something differently boring on Friday. Today I'm going to talk about Git, why you need it, some of the tricks you can do with it. And on Friday I'm going to talk about some of the lessons I've learned on big astronomical software projects, in particular the SDSS, over the last, these many years, since even Scott was a young man. So, if there's enough interest, I could talk about profiling at some point. I did prepare a lecture on that as well. Okay, so let's get started. And I should warn you that my laptop has now got a broken keyboard, so if I'm doing this enough times, it's because I'm pushing the wrong key. Okay, so first of all, why version control in the first place? So, have you ever tried to add a feature to a program and broken it? I can remember as a thesis advisor, well, not as a thesis advisor, a thesis student, taking every single line out of a large code, large by those standards, 100,000 lines of code or something, and throwing it away, piece by piece, commenting it out, until finally the segmentation violation went away, about 3 weeks before I had to defend. So yes, I have been there. This is not unrelated. Left a program in an unrunnable, or worse, uncompilable state. And of course, you need the results now. This should seem familiar, at least to some of us it's going to feel familiar. Or for that matter, try to work on a piece of code or a document, probably in LaTeX, with one or more other people. All those are cases where version control is going to make your life significantly easier. So there are solutions. First thing we used to do was you just make backups. You keep all the backups. That's not it doesn't scale, but it's very simple. Okay? Or you can only ever develop on a copy of your code. You always copy it over here and you keep the old version, and it's going to be fine. Or, of course, if you're really collaborating, you can get somebody whose job it is to merge everything together. You get a graduate student. This is the graduate student model of things. But fortunately, there is a better solution using version control systems, VCSs, which solve all these problems very much better than my proposals. And they have many other advantages as well. So, first of all, if you like the backup solution, many versions of CP, Unix copy command, support the -B flag. Now, this is an OS X laptop. OS X is not one of the versions that supports the -B flag. We'll solve that problem in a moment. So all you need to do is you need to run mkdir backups, then you say copy -B because of the magic -B flag, and you make a copy into the backups, you hack and you hack and you hack, and you do it again, and you do it again in a very disciplined way. And finally, you can do an ls, and you discover you have all these files with magic twiddles in, and you have a chance of going back to the version you started out with. So that solves the problem of ending up with uncompilable code. Now, of course, you have to grep next to find the version you actually wanted. But, you know, it's better than my thesis advisor needing the results now scenario. Okay. Now, of course, if there's no -B on your machine, you can write a single shell script. You see. This is, of course, a very slippery slope. Once you've written a little shell script, it's very easy to make it a little bit better. But fortunately, there's an easy way to do it, which is to use Git. Now, Git is a word, it's an English word, but which may or may not be where the thing comes from. There are various stories out in the literature, but the command is Git. Git in it, and it says something like that. And I wrote these lectures originally for a class I teach at the university called APC 524. You're going to see that magic string appear multiple times. It's not very interesting. And then git add dot, and you are good. And then we can have another hack session. We can say git commit -m initial version. Hack, 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 hack. And we keep on going. Great. So, first of all, those M strings are associated with the commits. That's useful. And I can list them with the command git log. And the --1 line, I'll tell you about in a moment. So it says, remove that confusing define, made everything global, all sorts of things that you really shouldn't be doing writing good software. But that's okay. Okay. Now, I know some of you are thinking, but I've got a little shell script. I could easily add commit messages to my shell script. But why bother? Because Linus Torvalds, who also wrote the Linux kernel, did the work already. It's easier just to learn to use Git. Okay, so a few details. First of all, when I typed this command, I actually got some chat, which said, committer Robert Lupton the Good on this machine, Baba Yaga, who was a witch who ate children, one of my heroines. Complaining about names and email addresses being not configured properly, please do this, tell me what your real name is, all that sort of stuff. So you just do that, do what it says, you just have to learn to be obedient, and you never see this message ever again. Now, in fact, I should warn you that I have some magic lines which those of you who've been using a program called CVS for the last 30 years will recognize, or RCS. So I actually alias git check-in commit, get commit to CI and check out the CO. The reason I warned you about that is that I may use those in some of these lecture notes by mistake. So if you see that, that's what's going on. Okay. So if you're starting your own project, you would start with this git command, git init, initialize. But often I actually want to steal from someone else. It's much better to steal from somebody else when you possibly can, in which case you would say something like this. You would say git clone, and I think Peter taught you all about this, that says get my stuff from git@github.com, Robert Lupton the good. Robert Lupton was taken. I don't like numbers like 12666 or whatever. So here is a repo. And this repo is in fact live. You can go out there, those of you who have GitHub accounts, and you can look at it and you'll see the examples I've used in this lecture. If I was a virtuous person, I'd have renamed it to PiTP, but that didn't seem worth the trouble. So that's why you're seeing APC 524. And that's equivalent to my saying, I've got a new thing, I'm going to add my files to it. So that's straightforward. Now, even when I'm working alone, as happens far too often, I often want to set things up so I can do this clone, because that way, when I lose my laptop or I drop my laptop or something else bad happens to my laptop, I haven't lost my work. So this is a way of saying, please, Dr. GitHub, keep a copy of everything I'm doing and you can pay for the disk. So that's a good thing to do. Okay. In fact, I think Peter talked about some of these. There are lots of ways to store Git repos. I'm using github.com. You can use bitbucket.com. If you're really a masochist, you can use SSH or HTTPD or the file system. There are lots of ways to do this. These days, it's pretty universal. Bitbucket's dying. To use GitHub, that's what I would recommend that you do. It's only dying quite slowly, but it's dying. So, and I'll go back to teaching you how to get started using GitHub near the end of the lecture. I think Peter may have covered it. So, now, when I typed git log earlier, I added this magic --1 line because I didn't want to see all this garbage. But when I type git log, I discover that the author was Robert Lupton the good. Robert Lupton the bad was eaten by a black hole. We conserved quantum numbers, so I got all the good ones. And obviously I did this ago in 2012 when I wrote that, and the message that I typed was remove that confusing define. So that's all pretty sensible, except what are these magic 9613186 CAF 30A, etc. strings? There will not be a lecture, there will not be an exam at the end of this class where you're expected to remember those strings, but they are intrinsic to the way that Git works. And they are these things called SHAs, SHA-1s, which stands for Secure Hash Algorithm. It's a very sophisticated acronym. It's 160 bits long, and it's an almost certainly unique fingerprint. If you think about it, there are many more than 2 to the 160, sorry, there are many fewer than 2 to the 160 nucleons in the observable universe. So you've got a pretty good chance that if you've got 160 bits of checksum, it's going to be unique. SHA-0 had a magic bit in the middle that the National Security Agency never told you how it worked. There was code they explained, then there was something in the middle, and you just don't want to know about that. And then there was lots of code that they explained. And most people thought it's because they had a little trick that if you knew about this, they could break it. So it turned out somebody else figured it out as well, so they've delivered SHA-1, which is what we're using. Then there's a thing called SHA-2, which I guess is probably cryptographically strong. But of course, I, not being an American citizen, wouldn't know if it wasn't cryptographically strong because they wouldn't tell me. So for all I know, SHAs are in fact breakable by the NSA. But all we care about here is that we take my beautiful source code explaining the structure of the universe and converts it into an opaque number, which is almost certainly unique. So, what have we gamed over copy-b? What did Git ever do for us? Okay. We've associated a message with the saved version. That's useful, but I know how to do that. We've used git clone as a way to manage offsite backups. I guess, I suppose that's useful. We've saved disk space. Oh, that's very important. By storing diffs rather than entire files. There was a time when that made a big difference, when your disk quota on the university machine was maybe as much as 40 megabytes, and it was quite easy to fill that up. These days, where we're buying 6 terabyte disks, that's not really a very significant advantage, so I might as well go back to capi-b. Except that's not true. It used to be true, but in fact, the fact that Git stores diffs is something that's going to matter to you, so you better pay attention to this. It's not just a matter of saving bits. And the reason is that Git doesn't think, what have I got? It says, what have I changed? It's a little bit, well, I won't go into that. So when you ask, what does my file look like? It sort of has a very historical view of things. It said, way back, long, long ago, it looked like this. And then I changed it like this. And then I changed it like that. And then I changed it like that. That's a perfectly valid way of thinking about things. It seems kind of stupid, but I'll show you why in a bit, why it's actually quite a good idea. And it'll matter. Okay, so what have we gained over CP? Well, first of all, I can ask diff to Git to show me these diffs. So if I say git diff between this magic number 140C443 and 8187A17, which is, I'm sure you remembered from the previous slide, it'll tell me the changes I made were that I added 3 lines here, and I removed that line which used to say hello world, and now I said for int I equals 0, I is less than eta plus plus I. For some reason, probably, I don't know why I did that. Okay, one thing is I didn't have to type out 160 bits, so I could abbreviate this. But even cut and abbreviated and pasted, chars are a nuisance, because even I can't remember those things. So, there's a shortcut. I could have said, show me the difference between the version 2 commits ago, that's what double twiddles means, and the current, and the previous one. That's kind of useful. Say you've broken something. You want to know what you've broken. Well, you want to go back and look at it. Ideally, the commit message says, I broke it. But generally speaking, people don't say things like that in commit messages. So, here's the difference between my previous version and my current version. That's also quite useful. So that's one thing we've gained. Okay. The next thing is we need a make file. Now, maybe you don't like make, maybe you like CMake, or you like scons, or something like that. But the point here is that I want to add a file. I want to be able to not type cc all the time. So I do that. I use Emacs, I create a make file, I type make, and I'm happy. And then I can use another git command, git status. And this says, I don't know about a file called makefile. I don't know about a file called hello. Now, hello is a binary, but it doesn't know that. So, how do you handle that? Well, that's pretty straightforward. But git status is your friend. It tells you what you want to know. If it doesn't say anything, everything's under control. In this case, it does tell you something. We have to do something about it. And here we go. So the first thing we can do, and this is worth doing because if you've got lots of binary files floating around in your directory, you typically don't notice that you haven't saved the changes you really care about that implement that brilliant neutrino transport algorithm or whatever. So it's worth getting rid of garbage. And in this case, I say add the string hello to .getignore, and get status is no more concise, but now it tells me that I've got a file I didn't know about called .getignore, which you'll be surprised to know ignores files from Git instead of hello. So we can get rid of all that. We say add it. So we tell Git that these files exist. And now status says, I know about them, but you haven't committed them yet. You haven't actually told me what's in there. And I'll tell you what this means in a moment. So we do what it says. We say git commit -m, added makefile, ignored hello. It tells me I've got 2 files changes. There are 3 insertions. These are the modes, all sorts of things you really never want to care about. And finally, hey presto, Bob's your uncle. Git status says there's nothing to do. I'm fully up to date. I'm a happy person. That was actually a pretty bad thing to do. Generally speaking, when you want to go back and look at your source, you don't want to know that you added makefile, ignored hello, implemented a new clever algorithm, and also did something else. Because then you're going to end up with a diff which is 5,000 lines long, and you're going to scratch your head and you wonder what you really changed. So you really want to go in and separate functionality to separate commits. This is the sort of boring stuff that you learn when you build big enough projects. If you're just working by yourself and your program's a couple of thousand lines long, none of this sort of thing matters. If you're working on 100,000 line codes or 500,000 line codes, where other people are also working on things, it's worth putting a bit of trouble into making sure that when you go back, you can make sense of each individual commit. When you go back, you can find what you did here, you can read the logs, you can find out why you did it. It's just a way of making your life easier by investing a small amount of effort now in exchange for significant simplicity in your life later. And I'll come back to that a little bit in a bit. Okay. You can actually fix this. You can go back in and say, but, I didn't really mean to put these things in, and I also added a bug and all that sort of stuff. You can be clever. There's a command, git rebase -interactive, by which you can say, no, move these changes to here, move these changes to here, forget about those ones. And you can do it all from the command line. And when I was a boy, I probably would have done. But actually, it's one of the very few things I use a GUI for. Git comes with a GUI called Git GUI. That's very clever nomenclature. So the string would be git space GUI. Then there's a package called source tree, which is free. It comes from Atlassian. Atlassian are a software company best known for producing Jira. For some reason, I've never quite understood. They don't charge for source tree. It's not bad. If you like GUIs, it's probably the best way to go. I think it only runs on OS X, but there are other free things out there. One of the classic objections people, especially from a thing called Windows, I've heard of Windows, object to about Git is it's very command line intensive. There are these days GUIs that even run on Windows, I'm told. Okay, so ls-cap-a. Those of you who know Unix, I hope all of you know that -cap-a says show all the files in this directory, even ones beginning with dot, except dot and dot dot. It's much quicker to say ls-cap-a. And you'll see that we have a .ignore file. I knew about that. A make file, this thing which I've told Git to ignore, but I never told ls to ignore. And my source file, hello.c. But what's this magic thing? What's .git? And it's a secret. It's called the repository. But fortunately, it's just a directory and I can look at it. And if I do an ls on Git, it's all sorts of garbage. It's got files like index and orig head and fetch head and commit edit message twiddles. If I look at some of the files in there, they look like 488.2a1ff, and you now know that's a SHA. In fact, if I do a git log command, you'll discover that that number and that number are the same. So these are the files internally where Git stores all my valuable stuff, all my change sets, all my messages, all those sorts of things. I recommend that you never poke around inside this directory. If you're desperate, you can. There's no need to, but it's just a file. You could back it up, you can copy it, you can tar it, you can do whatever you like. Okay, so let's go on. I edit hello.c and I ask Git what's going on. And the answer is git diff, and it says, well, what you really wanted to know was the difference between these two files. It's just the way it does it. These are some SHAs, that's a file, that's a permission, that's 644, read, write, read, read. And it tells me that what I've done is I've changed hello world into goodbye universe. No problem. So I commit that. So I say git commit -m. M, for some reason, which must go back into the mist of time, I don't know, is how you introduce a string. So I'm going to change the sign of the greeting. And I type that, and it says, no changes added to commit. Use git add and/or git commit -a. Well, that's irritating, because I told it to do something and it didn't do it. Don't like computers that don't do what they're told. But it does tell me, it gives me some advice. I don't really like computers that give me advice either, but you know, it's better than nothing. So what does it mean? And the answer is that I didn't tell you about all the layers in here. Here are my files, and I have files hello.c and another file, in this case a make file. The Git adds it to a thing called the index, also known as the staging area or cache, which is a terrible name for it because cache means other things. And then finally, git commit goes from the index into the repository. We know that's this .git directory. So there's another layer that Git has. And some people think this is a wonderful thing. And some people think this is a terrible thing. And I'm going to hope to convince you that it's a wonderful thing. And if you don't think it's a wonderful thing, then go and use Mercurial and you'll suffer. So when I want to check my changes in, I first have to add them, and then I have to commit them. And if I do that, it's no problem, and I get a message that the master CE 18930, which is a SHA, change the sign of the greeting. So, and what we did was, you will notice, that we added this change set, not the file. So this commit just remembers the changes. I told you earlier we were only handling changes. Here's we're adding the changes. Okay. Now, if you're familiar with CVS like Peter, you moved on to CVS from RCS, didn't you? Yeah, okay. You're still in CVS. Better than SCS. We'll come back to that. Or even SVN or Mercurial. You're probably thinking, this is a really dumb thing to do. Why should I have to deal with this extra layer of complexity? Well, one thing is that I didn't. I could have said, add everything by putting a -a in, and then I would never have known. And then some of you are thinking, why don't I just alias git commit to git commit -a? And in fact, you could do that. I showed you how to make other aliases. Okay, so here's what's going on. Git add takes files from here and puts it in the index. Git commit takes you down from the index into the repo, and then there's an arrow that skips the middle thing altogether, git commit -a. And in fact, you didn't even need to do that, because I could just, if I specify a single file, Git is clever enough to say, let me think, I bet they wanted to add that one, then commit it. And it does, so it just goes straight through. So, however, usually you've got lots of files, changes in many files that belong together. You change your .h file, you change the .cc files, maybe you change the tests, they all go together. And you want to manipulate that set of changes as one. Say you decide, I didn't want to add that extra feature that did this. I want to take all of it out or none of it out. I want to make atomic changes. Because it's much easier to think in a finite number of atomic changes with particular pieces of functionality rather than I modified this file, then I modified that file. And that's why change sets are worth thinking about. You can think about them as being something that makes sense to a human, not to a computer. Computers can think about individual files, but I can't. So, generally speaking, you've probably made other changes that don't belong together. You know, you put hacks that got in the way, you disabled some of the tests because they took too long to run, but you don't want to put those in when you do your commit. So, the ability to mix and match what goes into the index is actually quite valuable. And you can do that down to the single line level. If you're a masochist, you can do it with git add -p, but I would actually use a GUI or something like that. Okay, so I promised actually, that git clone offered us a protection against disk crashes. That's an important thing for me. So this is growing my diagram a little bit further. Git clone took somebody else's stuff way out on the cloud, sitting out there in the world of GitHub, and it pulled it over to me. Git push does the opposite. So I can do vertical changes, I add my files, I commit them. When I push them, they go out either to my backup somewhere, or to GitHub, or to a version in Japan that I use sometimes. So git push does that. So, commit messages. Here's a question. Who needs good commit messages? Let's have an interactive session. David, who needs good commit messages?
We all do.
Very good. Excellent answer, David. Okay, different question. Isn't it more efficient to save time by typing less? Scott. They are good. There's a reason why we have two ex-heads chairs of the physics department, of the Astro department in Princeton here. That's right. So good commit messages start with one beautifully composed line. And then they sort of go into all the details you really don't want to know about. So it's actually moderately important to have one line that's useful. Some of the tooling even supports that. When I was doing git log -- one line, I just wanted the summary that told me I was interested in. Okay. But then when you really want to know why you did that, and you cannot remember why you replaced pi by 3 everywhere, but you think there was probably a good reason, that's when you want to go into the thing here that explains that it was really a pretty good approximation because of two-dimensional GR or something and angle deficits. Okay, now you should remember that when I'm talking about desperate readers, you're not thinking about your students, you're thinking about yourself. You know that that paper is going to earn you another Nobel Prize, but you can't submit it till you have the code working again. That's when you want to go in and say, what on earth was I thinking? Help, help, help. And then you clutch at straws. And it turns out that commit messages are quite good straws. They have quite a lot of buoyancy. They can really help you. Okay, so what was the state of hello.c 2 revisions ago? Well, I can get that. That's the magic command. Totally obscure. It is not in the least obvious why that should be the correct command. I'm sorry, that's the correct command. That's like saying, why is a knight in shining armor spelt K-N-I-G-H-T? Well, it's because it was chnicht in Old English, but that really doesn't help you very much. It's just the way it is. Okay. That shows me the change set. That's how you show the file. There's a colon in here. Obscurities, this is where Stack Overflow comes in. That's probably the way I found this when I first wanted to know about it. I'm sorry, that's the way it goes. And I can get back an old version like this. I can say git checkout this hash hello.c. Now, there's a minor problem here, which I'll come to in a second, I guess. I can get back to my original set, my state like that, or by saying that. Now, if I say with some magic number in there, I'll get a message that looks like this. Now, what does that mean? It says, note, checking out 8187A17D, your friend. You are in detached head. What that means is, I'll give it to you, but I don't know what to do about it. If you make changes here, they're going to get lost. That's probably not quite what you wanted. You can actually almost never lose anything actually in Git if you know how to find it. I can't remember if I put those slides in. But it says you can look around, make experimental changes and commit them. But you will lose them if you're not very careful. So, yeah, I don't know where to store anything you do. There's a workaround. I'll tell you how to deal with it in a moment. Let's keep going. And you can get back to your original state like that. So, it's a pain to always talk about head twiddles 3, because when I make a change, it goes back to being -4 instead of -3. So how do you work around that? Well, the traditional thing to do is to refer to 4882A1F, but that gets old very fast. So you make a post-it note, which says, the version 1.0, which I posted to sent to all my collaborators as a tarball, and I sent to Obama apparently, was 4882A1F. So I put that on my laptop, and if I don't lose that, then I can figure out which version went to Obama. Safe, totally safe, but somewhat impractical. Fortunately, there's a way to get around that, which is to give it a name. I can say git tag v1.0, that's what I call it, that's what v882AF is. So that's progress. I can now say things like git show version 1.0, and I can forget most of my SHA. And in fact, I can use v1.0. It's just essentially an abbreviation for a SHA, okay? But of course, I still need my sticky note, because I want to know what version it was that I sent to Obama, what this string was. But you can get around that too. I can put a name on that, and all is well. There we go. That's wonderful. I could, in fact, have done that from the very beginning by using get-a, and that works slightly better. It's probably to be recommended. Now, I worry about my colleagues. They'll masquerade as me and get me into trouble. So as to make certain that the version I sent to the Kremlin was really done by me, I could actually sign it, cryptographically sign it. So in that case, I can prove that V1.1 was the one that exposed the secrets of Mercad Telluride detectors or something like that to Putin. And that message is totally obscure, but it basically means, yeah, we're fine. So if you're worried about sending out versions to the outside world, you can actually sign them, everything is fine. I don't see any reason to do that. I'm not paranoid. If you're paranoid, we can deal with that. Okay? So, blame. You can spell git blame, git annotate, but blame is so much more satisfying. So you say, why did they do that? This is I should warn you, this is a slightly double-edged wet sword, as you'll see in a moment. So here's the output of git blame, and I shortened some things. And the problem is that I was looking for this thing and for this change, and it turns out it was me that did it. So this is why git blame is sometimes, after you've sworn that only a moron could possibly have written that, it turns out that moron was you. But that's the way it goes. So you can recover the SHA, you can find out that the problem was that that Lupton guy, RHL, removed the confusing define that actually made the code better. And if you're using Emacs, you can actually use a thing called vc-annotate in Emacs, and you start out with source code that looks like this, and you can ask it to show you for every line what the message was, and they're color-coded. You can't see that in red by which was the thing you changed most recently. That's a pretty good bet, actually, because when you've written a piece of code and it suddenly stops working, the chances are something you changed recently was what broke it. So you look for the red lines and you say, okay, that's probably where the bug is. Okay. How do I know that my code will compile? This is a problem. I told you that you should carefully choose exactly which changes that go into this index, and you delete this line, you don't check in this line. But that means that the version I actually put into the repo may or may not actually compile, because I never actually compiled it. That's a very good question, unfortunately. But fortunately, I also have quite a good answer, which is there's a subcommand called stash, git stash, which perhaps not everybody knows about. So here we go. Here's my git status command. It says, I have modified hello.c, and this is how you can get rid of it. And then I say stash, as in save it. And it says, I saved everything, and I don't know what WIP stands for, into a secret place. And now I've got nothing left. So this essentially says, take all the work that I've done and not told Git about, and save it away. And then I can run the code, I can confirm that it actually compiles, and I can get it back. I find this a weird word for it, but it's what they call it. Git stash pop, I get my changes back, and sure enough, when I try to compile it, it doesn't work. So this is a very convenient way of cleaning up, of saving changes. So you've been working on something, it doesn't quite work, and you say, I want to go back to the last version I know worked, I want to run a few more tests. So what do? You make a tarball and put it in your back pocket? No, you just stash it. And you can give it a name, and you can have whole bunches of them. So this turns out to be a surprisingly useful thing to do. You do it all the time, because I do it all the time. So git stash is one of your friends. Oh, yeah, in this case, I don't like it. So this command says, just forget about all the changes I've made. And that's one of the very few commands in Git that will actually lose you work. Almost everything gets hidden somewhere. Actually, it won't. It takes about a month for it to forget. If you really want to, you can do all sorts of git fs test, no ref log, awk, dangling commit. There are commands you can use to find things back. When you're desperate enough, you do that. I do it seldom, but when I do it, I'm grateful. So that's how I can get that particular change back. Okay, now you've been going to the PiTP, you've been learning about great new algorithms that do things instead of Gauss-Hermite integrations or whatever, and you decide that maybe this piece of code I've been working on wasn't quite as good as I thought it was. Let's go back to the beginning and make those changes in a different way. So what should you do? Well, you could go back and make a copy of one of your backups, but an easier way to do it, in this case, I suppose this is more relevant if you're taking my software engineering class rather than taking PiTP, I got a branch. I say, make me a branch called refactor at the point 140. That's at the initial thing. And then I say, switch to that. Switch to branch refactor. So what I've now got is, I've got two totally different versions of my code. They exist simultaneously, and I can switch between them. And in this case, I think I put it out. Right. I've got back the original version. I've still got this define initter 10 at the top of the thing I took out by removing that annoying thing. It's the initial version, and as git log would have told me that. So that's useful. It means I've got two different versions of the code running at the same time, and I could have saved some typing by doing it that way. So what's the difference between a branch and a tag in Git? I've got a tag, which is a name for a SHA, and I've got a branch, which looks as if it's also just the name for a SHA. I've said branch, some SHA, SHA1. So the difference is that a tag is the label for a particular change set, whereas a branch starts out as being the label of a particular change set, but it keeps moving. It sort of floats. Think of it as floating up. And I've probably got a picture that shows that. Okay. Oh, they're labels for change sets, not files as well. So they're talking about, this is the point I got to, and there's a whole chain back of change sets. Fine. So, do I care about that? Yes, I do. I started way back in prehistory, before my makefile. What should I do? And the answer is, I can say git log --grep, grep as in the Unix command global regular expression print, which is where it comes from, grep makefile, and I discover that I added it in this SHA. And then I can use this command, cherry pick. Cherry pick's a weird name for it. This says, get me that version and add it and merge it in now. So because I have now a change set that does something useful, I can apply that change set to what I have now. So, that's right. So this is one reason why it's a useful way to think about Git as maintaining a set of changes, because I might want to move one from one place to another. Here's an example where I do. And that had the effect of grabbing makefile over. It also grabbed the .gitignore file containing hello. And that's why I told you this was really a bad idea, because I probably didn't want to do that. I only wanted to do that. So that's why orthogonal sets of changes makes your life easier in the long run. And now you'll see that the get status command tells you I'm on the branch refactor with nothing to commit. So the cherry pick copied the files over and also did the commit. So it's a way of moving history from one place to another. Okay, philosophy is a big word. Git-k is related to this Git GUI thing, and this tells me what's going on. So here is my initial version, and here are all my changes. So I made everything global, I removed a define, I added a makefile, and I called it version 1.0, that's a tag. I changed the sign of the greeting, I called it v.1.1. I changed the wording to be less assertive, I must have been taking some class or other. I worried about I overflowing, which was a really stupid change set. And then I did this. Whereas I also said, go back to the initial version and pull over, added makefile, ignored hello. Right? So I've got two trees, one running up through here to that point called master, that's the default version I use, and one running up to here. So the other tools, the source trees, is a thing from Atlassian. The yellow labels are tags, blue or yellow circles are change set with associated SHA-1. So my entire project is a DAG, a directed acyclic graph of change sets. Okay. Now, I never ask for a version of a file. I always say, start here, add these changes. And some of those changes do things like add files. And that's what I used here. Okay, so sharing things. We learned to clone things. We learned, in this case, to clone my APC 524 lecture that we're talking about here today. So what happens if somebody else just uses the same command on their laptop? Well, nothing. They get their own copy of my code. They Don't steal it from me. It's not like a move constructor in C++ 14 where suddenly, C++ 11, where suddenly I don't own it any longer. So, much scarier is, they've got a version, they make changes, and they push the results. And then I make different changes, and I push the results. So we've now got two different versions, and which version should Git accept? Does it have a sort of hierarchy that I'm more important than you, so it accepts my version? Does it have an understanding that you're smarter than me, so it accepts your version? Well, no, you asked the wrong question, actually. Because we don't push files, we push change sets. So they could accept both of them. So what you meant to ask is which change set to be applied? And the answer is all of them, because it doesn't know that you're smarter than I am. So here's what goes on. So we have, I find a bug. It's a pretty stupid bug, actually. Somebody's worried about I overflowing. Those of you who write C++ 11 or C++ and use the STL will know that they use unsigned integers in places that are just annoying, like the size of containers. So people use unsigned int so to save nothing. Somebody did the same thing here. So here's the bug fix we did first. We applied this change. We changed int I to unsigned int, and we pushed it. So that was developer A. I'm not saying whether that's you or me. If you want to push your tags, you do it that way. OK, what did B do? B said, instead of telling you something, I'm going to mention it. It sounded a bit nicer, really. So I make this non-overlapping change, and I push that. So where have we got to? The answer is that I say git status, my branch is ahead of origin master by 1, I've checked it in, and I do this, and this is what I see. Okay, initial version, and I've got my changed wording to be less assertive. And then I try to push it, and it says you can't. It doesn't say it very helpfully, but it's what it says. It says you can't push it because something is not up to date. That's what it means by non-fast forward updates were rejected. So we do what it says. They're about refs and about change sets. We're not talking about files here. OK, so let's do what they say. So I do a git pull, and it tells me all sorts of things I don't care about. It says auto-merging, and then finally it says my branch is ahead of origin master. That's the remote version by 2 commits. No problem. And I can then push it, and all is well. And at this point, I have successfully made my change, merged your change, and then pushed things out. OK. What does developer B have? Well, this is what developer B has when they do a log 1 line. Switching back to developer A, we do a git status, we do a git pull, and it says, fast forward, we're going to pull things in, and that's just great, no complaints. So we have successfully now got an identical output. So I don't think I listed that. So this is a way that the program is successfully able to move change sets from one place to another. All is well. You don't need to understand anything here. It just worked. So what's going on? Question? Sorry. So we've seen a few more commands. No, we haven't. What's the difference between git push and git fetch? Basically, git pull does, git push pushes in that direction, git fetch pulls in that direction, pull, and a git clone does this. So we've seen all those commands now. OK. Now, remotes. I think nobody's... So here's how you say, where is stuff going to go if I try to do it? Git remote, show origin, it says things like this. In general, you can push to multiple different places. This is where my stuff is. Yes, that's, I think, private. We'll figure that out. So it's worth knowing about that. I have abbreviations for all of those things. It just works. So why is git fetch interesting? And the reason is that if I fetch the changes, I can ask what the difference is between my version and the version that's at the origin. I can see the changes that are going to be made. So when you're a bit nervous that you don't know what Anatoly has done, and you want to know what's going to happen if I do a pull, if I do a merge, this is how you do that. Again, it's a somewhat obscure way to set of commands. OK. Fine. So I then see git merge, that says, get me these changes from fit, and it says you can't. So you fix that, and you set a configuration option, and these problems don't happen again. So there are some things that just require magic commands to be issued. You probably won't see them. If you do, again, this is the sort of place you go out to Stack Overflow and you try to figure out what's going on. Okay, so there's also the difference between rebasing and merging, and I don't think I was going to go into a lot of detail on that. Yeah, I'll come back to rebase later. Okay, I can push branches. So if I'm working on my piece of code and I want you to know about refactoring, I can say git push -u, which stands for, I don't remember, U stands for upstream, origin, refactor. And that means that I can now make my version available to you. My collaborators, this is how you do that. And then they can do exactly the same thing. In the old days, you had to do that, but you don't have to do that any longer, so let's not even worry about that. Now, I'm not sure if anybody's running old enough versions to this to be a problem, but if you're running an old version of Git, you can get very confused when you try to run some of these commands. You get messages that, do I get the messages in? No. I think I'm going to skip over that. Okay. What happens when you fail? In the old days, even before CVS, we forbade more than one person to work simultaneously on the same file. So if I was working on my program, only I am allowed to work on this program. And that wasn't very practical because typically somebody else was working at the bottom of the file and I was working at the top. So somebody, I think it was Brian Berliner really, who was the CVS guy, said, that's stupid, let's not lock things. And in fact, it doesn't actually solve the problem anyway. So now you're allowed to make get conflicts. I change this line and you change it too. So here's an example. I go in and I say I'm going to add return 0 at the end of my main program, which returns the success code to the shell. I think, in fact, the C standard defaults to that, but I didn't know that, or developer A didn't know that. And that's fine. I commit it. I specified a file name, so I didn't need the -a. I do a push. Everybody's happy. But developer B is also happy. They found the same issue, but they spelt return 0 as exit 0. It does exactly the same thing. They put the same thing, they committed it, and now we try to push it. Okay. It says rejected. Same thing. It's realized that there are changes out there in the cloud in hello.c that we haven't seen yet. So the solution is to ask for them, make sure everything's fine, and we'll push it, just the way we did when we made some other trivial change, which I now forget. Okay. We can do it the cautious way. I never bother. You can say, get me the thing that's causing trouble, ask me what the difference is, and the answer is, get diff between origin and me. Somebody wrote return 0, and somebody wrote exit 0, but it's the same line. There's no way to merge that. No merge tool can sort that out automatically. So what are we going to do? Well, what does Git do, actually? It complains. You do a git pull, it says conflict, capital letters. Merge conflict, auto-merge failed, fix them, and then commit the result. And in fact, if I look at the file, it does this. It says, this is all just fine, but look, the version that was on head is exit 0. The version that was on this SHA was return 0. You, decide what you want and fix it. So you go in and you decide which version you want. The humans come to a conclusion. In this case, we run Emacs, we clean it up, we add it, we commit it, and all is well. So there's no particular problem here, unless the changes are very complicated. And this is another case that if you have a commit, a change set that's 1,000 lines long, you have to sort out which was going on, which changes were there, which changes weren't there. If you keep your change sets reasonably small, self-contained, and understandable, this doesn't happen so much. But having resolved the problem, the push will just work, and it's all fine. And developer A doesn't have to do anything. Okay. So, after all those operations, what does my DAG look like? And the answer is it looks like this. So here's refactor. That I've been making these changes. I got 2 versions of return success code to the shell, and they all got merged. So the DAG just goes around. It's not very clean. It's not very tidy. This isn't particularly interesting that we went, this merge was, we had 2 parallel changes. Somebody changed one thing, somebody changed another. There was no conflict, there was no problem. You can get around that.
Is there a program that makes that DAG diagram?
Yeah, this one comes from Git K, I think. Source tree does the other one. I'll show you that in a moment. They're kind of useful. There are ways to get around this, which I'm not sure I'm going to cover. Okay. And the answer is you can use rebase to do this. I think I'm not going to talk a lot about that. But by being slightly more careful and using rebase rather than merge, you can end up with a DAG that looks like this, and it's much easier to read. So there are things to do that. The reason people like linear histories is because it makes it easier to cherry pick things, to merge things, and such like. Okay. Okay, here's the other one. Here's the other source tree. There's another way to do it. You can do a pull-rebase, and you then end up with, this is the other tool that makes you a nice linear history that doesn't have these loops in it. You can understand what's going on. Again, this makes a bigger difference if you're working on a big piece of code with many other people, because everybody's pushing change sets and pulling them, and then it's worth some trouble to make sure that the history looks sane when you're doing it. So some of these tools don't seem worth the trouble to use very cleverly, and they're not for small numbers of people, but for large numbers of people, things add up. And there's a lot of Sturm und Drang out on the web saying linear history is really important. And when you've worked on a big enough code, you begin to think, well, it's overstated, but actually they're correct. Okay, some of you probably like the SVN way of doing this, or even CVS, which is essentially similar here. It's all so much simpler. We don't have indexes, we don't have pushing, we don't have pulling. All we have to do is to say check out, commit, update. It's just so nice. I don't lie awake at night trying to remember how Git works. However, actually you now know that under the covers, SVN update does a stash. It saves everything you've been working on. It does a pull --rebase, which is to make all the changes fit together nicely. And then it stashes, then it gets the stash of changes back. That's all very well when it works. The trouble is it doesn't always work. You get merges, complicated things happen. And because those things happen under the covers, in the days I used to use CVS, SVN, I always used to tar up my repositories before I did anything serious, because I just knew I would get confused. The advantage of you doing this sort of thing using a tool like Git is you sort of have step-by-step control of what's going on. You can back it out piece by piece. So SVN's really not that much easier. So how about some other commands? Some of these are cool. Git bisect, I think I'm going to talk about that actually. Binary files. This may not be an issue for anybody in this world. I don't know how many big binary blobs you have that you handle. If you're doing web development, which I don't do, then it's reputed to be a big deal because you've got icons and pictures and all that sort of stuff. It's quite a big problem if you're doing image processing where your test cases may have got big blob files in, big binary images. There's a trick. In fact, a common mistake, and I'm sure some of you have done it, is to check a binary into Git. The trouble is that makes everything bloated, because once you've added it, you can't take it out because you might want it back. It doesn't know you want it. This is the way you deal with it. Very topical. I'm told there's a movie out. I don't like Roald Dahl anyway. The official way to fix that problem is use a command called git filter branch, which is complicated. Use Stack Overflow. There's a thing called BFG that just does it. But more interesting, what happens if I really did want to add big binary files? And I'm going to go through this pretty fast. There's a way to do it. Again, you can just Google for this, Google for git LFS, and you will find it. And there are magic ways to do things. And I can now safely do a git add m31.fits. I can commit it with a message, and I can push it. So these days, tools like Git can hand binary files up to about 1 gigabyte for free. The downside is that beyond 1 gigabyte, it's going to cost you $5 per month per 50 gigabytes, or else you can do it yourself. There are ways to do it. So, binary files are a solved problem. Now, here's another more interesting use of Git. This goes significantly beyond copy-b. We all know how difficult it is when something is broken and you don't know when it was introduced. In the real world these days, you do that via unit tests, so you make sure that things get tested every time you compile. That's actually quite hard to do. I may get a chance to say more about it. But you still get to the situation that at some point you know you broke it. This used to work, it doesn't work now. What am I going to do? So the example I have was I gave a lecture on Python. Here's the commit messages. I renamed LC3 to LC-C. I added the KCD cartoon about pointers. I made a few fixes after the lecture, and then I started working on the class debugging 2. Okay, which of those commits caused me the problem? In this case, it's pretty clear that fixes post-lecture is what caused it. But let's be a bit more formal. So, we can use a command called git bisect. Git bisect start, that says I want to start doing this. And you say, I am bad. There is no good in me. Things are broken. And then you say, it was good here, at that commit. And then git bisect says, I'm going to give you something between here and here. Try it. So it gives me a version. I run make, and it fails. And I can say, that one was bad. So now I've trimmed down. I used to have this many commits. And by binary search, I can say, was the problem introduced here? Was the problem introduced here? Was the problem introduced here? So in logarithmic time, you can find where you introduced the problem. For big codes, this is actually really useful. And then when you're finally done, you say, this one was good, this one was bad, and Git will tell you where you are, and you can go in, and in this case, the problem is indeed at fixes post-lecture, and we're good to go. Okay. Back to the size bug. If you have a command that reveals a problem, you can even make git do. I would revert to the previous thing, so git checkout head twiddles will get you back to that. Okay. So if we have a command that reveals the problem, so I can write a script that says make bug 1, run valgrind, search for this, right? If I say, if I fail to run make, then exit 125 is the magic, look it up, command for saying ignore this thing. I run valgrind. Valgrind is a program for looking for memory leaks. If I find in the output from valgrind running Perl that it says I definitely leaked something, then I exit zip 1, otherwise I'm fine. So then I can run a command git bisect start, git bisect I'm bad now, I was good here, run a bisection. For each of the versions you find in Git, the sector change sets applied, run my test, and it'll go through, it'll check out a version, it'll say it failed, it was good, it was good, it was bad, it failed, and in logarithmic time, it will tell you where your problem was. That's worth knowing. It's not the first thing I reach for, but it's about the third, maybe, when there's something really stubborn, you read the source, you can't figure out when you broke it, or somebody else broke it. This works when you do a pull and things start failing, scientifically failing. You can find the student. So, RCS, or CVS, or SVN, or Mercurial, or Git, or Bazaar. There are lots and lots and lots of source code managers out there. There are ones you can spend a lot of money for. There are ones that come from Microsoft that don't work and they don't use internally. The choices are enormous. 20 years ago, something called CVS replaced the original traditional things, SCCS and RCS, whose names I now forget. That was easy. SVN was supposed to be a better CVS, which came out in around 2004. Around the same time, 3 other options appeared in the Unix world. Bazaar, BZR, Git and Mercurial. Mercury, ha ha, joke, etc., etc. Yeah. Okay, so which should you use? Does it matter? I'll give you some advice. Use CVS if you have legacy code in a CVS repository. But you should probably move to SVN. It's not much better, but it's a little bit better in lots of different ways. Use SVN if you have legacy code in SVN repository, you're lazy and want to learn as little as you can get away with. Otherwise, you should use Git. Conceivably Mercurial, I personally don't like it, some people do. I think Bazaar is slowly dying. So at this point, I think you should just use Git. So I consulted the Oracle. The Oracle said that Git was currently the answer with 42.9% of professional software developers. One should be very suspicious of numbers like 42.9%. As opposed to 36.3% or 32%. Okay, this basically says lots and lots of people are using Git. And if you go out to Black Duck Opens Hub, which used to have a different name, which I've now forgotten, OLO, I don't know what that meant either, 39%, as opposed to 42.9%. So here's the 2014 graph, and this is, I think, for all the open source software products they could find, going out and looking at all the servers for them. Subversion was at 48%, Mercurial was at 2%, Bazaar was at 1%, CVS was still at 9%, and Git was up to 37%. I just updated that today. The changes I thought were remarkably small. People are very conservative. Git's up to 39%, it all came from Subversion. People stuck in CVS. My guess is that what's going on is that these are old packages that nobody's messing with. They're still there, they get a commit every few years. Ditto for SVN. So, should you use SVN? Email on the GDB. GDB is the GNU debugger. Mailing list from Jim Blandy at Red Bean. As one of the original designers of SVN, I would forget about it. I wouldn't do it. I would skip. Once you switch, you will love the speed so much you'll cry when you have to use CVS. And they moved to Git. Okay. So, then the sharing using GitHub. GitHub is, I think, one of the major reasons why Git is getting really popular. I mean, it is really popular. It has been for a number of years now. I have a GitHub account, Robert Lupton the Good, because Robert Lupton was taken. So I created a new repo called APC5 GitHub, and in that case, these lectures, this test repo is a real repo, you can go and pull it, is done by saying git remote add origin. That says, when I have a remote, I want the origin to be bleh, that long, boring string. Then I did a git push -u origin master, and all these examples went out to GitHub. That's all there is. If you want, that's probably a live link in my lecture notes. You can go and look at it, you can poke it, you can clone it, you can fix all the bugs, you can do whatever you like, but yeah. So you can get a copy of that. You can look at the history. Somebody was telling me at lunch, I don't want everybody to look at all my history. They'll find all the stupid things I did. It's like airing my dirty laundry. Well, I have a little sympathy about that. When I read other people's code, it makes me feel like a psychiatrist, thinking, they think like that? It's so simple, but somehow they make it look like this. But that's life. It's interesting. Sometimes it's interesting to find out why people did things, or if you want to make changes and you want to know what happened. So I personally am no longer embarrassed that you can find all sorts of horrible things that I've done in my past out on GitHub. Some people don't like it. There are ways to get around that. I'm not going to teach you how to do that. But of course, if you're a coward, you can have a private repo. They just cost a bit of money. If you're education, you can get them for free. Bitbucket offers free hosting for 5 or fewer participants. You can run your own. I wouldn't personally bother. So finally, I thought I should put a picture in here, if that's what I do for a living. This is the Behustan inscriptions, which are famous for having this inscription written in cuneiform in Old Persian, Elamite, and Babylonian. And I think this was how they first cracked Babylonian, by reading the same inscription which says, I am Cyrus, King of Kings, etc., etc. So the equivalent of the Behistun inscriptions to translate Git into English, or even worse, American, is here are most of the commands that I've been running. So this is the translation. If you speak Git and you want to speak English, that's the way you go. And I can't remember, did I put in, yeah, here's the corresponding translation inscription for converting SVN for Git users. They're really similar. The things I've been talking about were supposed to give you some idea of how these things work and why these things work. But in practice, unless you get into trouble, the commands are basically the same. You say git status or SVN status. Hey, you could have guessed that. That one's more obscure. And I think I didn't bother to put in the translations between Mercurial and Bazaar and things like that. Okay, so that's Git. It's worth using. All these little things, you were probably sitting there thinking, I knew that, I didn't know that, that's worth knowing about. You don't think you need to understand how it works, but then you discover that something happened you didn't understand, and you do need to, and then you go to talk to your local Git expert who explains it to you nicely. You can be your local Git expert. You can become famous. You can get your professors to come flocking to your offices asking for help. And more importantly, you'll save time and you'll get closer to getting your next paper written by using a tool like this. So, I'm done. That's it.